And it looks like we have some really exciting geological discoveries coming from China. And you can kind of see it pictured right here. An unexpected discovery of a previously unknown meteor crater that seems to have been formed in relatively recent times and seems to have been always there, but nobody really noticed. A crater that has not been officially confirmed and is referred to as the Jinlin crater, and a crater that seems to be the largest created during the period referred to as the Holocene, or basically the Age of Humans. In other words, there's actually a really big chance that someone out there might have witnessed the formation of this back in the days. And so let's discuss this discovery in a bit more detail, but at the same time let's discuss some other discoveries in regards to other recent craters that might have been witnessed by someone out there in the last 12,000 years, and also talk about why this kind of matters, but also discuss if there is any chance that any of these craters may serve as evidence for the now controversial younger Dryas impact hypothesis, something we'll discuss in a few minutes. But I guess first let's start with the idea behind these impacts, and of course the idea behind asteroids. And so even though most of the research on the solar system usually focuses on lurking threats in outer space that might one day collide with our planet, we can also learn more about these threats and how frequent they are by trying to find some of these impacts on the surface of the planet. But today, we've only identified approximately 200 craters on the entire planet, even though we obviously expect so many more just based on what we see on the surface of the moon. And that's because pretty much most of these ancient craters have already been eroded, deformed, and buried due to a lot of tectonic activity or because they were formed in the oceans. But in the last few years, based on some of the new methods, scientists have discovered at least a few more impact craters, some of which have been sort of surprising. As a matter of fact, the largest crater, discovered in Australia, was only found approximately 1 year ago. There should be a video about this in the description. But now scientists have also confirmed this: a well-preserved structure in China that may force us to update our understanding of how frequently some of these objects strike our planet. Because in this case, this seems to have happened in the relatively recent past. And so this new discovery is definitely pretty exciting, and so let's basically dive in and discuss some of these more recent craters in a little bit more detail. And so once again, this is referred to as the Jinlin crater, located on a hillside in the Guangdong province of southern China, and representing the first confirmed impact crater in southern China, the region that's actually known for one thing: widespread deposits of granite and intense chemical weathering because of very high rainfall and super high humidity. So a lot of these geological features don't really survive for a very long time. But this crater survived because it seems to be pretty young. First of all, this is actually pretty large. It seems to form this very unusual elliptical bowl-shaped depression and is between 820 and 900 meters across, or almost a kilometer in size, with the apparent depth of about 90 meters. It's also somewhat tilted, which is consistent with some kind of a rock crashing into the mountain, specifically the slope of the mountain, with the top of the mountain basically being destroyed. But here it's not just the shape, it's also the composition that definitively proves that this is an impact crater. By analyzing a sample of rocks and mineral fragments, scientists discovered specialized microscopic structures inside the quartz grains referred to as planar deformation features. And these are usually produced through some kind of a shock phenomenon, where huge amounts of pressure on the rock suddenly cause these deformations. And so on Earth, to form this, you usually need to have a lot of pressure, anywhere from 5 to 35 gigapascal, which would be very difficult to produce using any other geological process, such as volcanism or tectonic activity. But impact craters produce these all the time. And so here there's a lot of evidence that this was produced by a meteoroid. And based on the size of the crater, and by knowing that there's a lot of monsoons here and a lot of heavy erosion, we can then start to estimate its approximate age. Now right now the exact age is unknown, but because the current geological epoch began approximately 11,700 years ago, scientists believe that the age for this crater is early to middle Holocene, so essentially in the last 11,000 years. We don't know exactly when yet, but it has to be at least a few thousand years old. And this estimate is based on the fact that this is a remarkably well-preserved structure. For context, a lot of granite fragments smaller than 30 centimeters usually completely degrade and become weathered in less than 10,000 years. But the pieces inside this crater are only partially degraded, implying that it must have formed within that time frame. But because it's not that big, we also know that it must have been a somewhat small in size meteoroid, very likely 30 meters across, moving at about 20 kilometers per second. and anything larger than that would have left a much bigger crater. But of course, one of the main reasons this is so significant is because this is literally the largest such crater formed in the last 10,000 years. And importantly, it exceeds the previous record holder, Russia's Macha crater. This one is about 300 meters in size, or approximately 3 times smaller. And this too was formed approximately 7,000 years ago, but by something a little bit smaller in size. Nevertheless, this collision produced an explosion somewhat equivalent to a small-size nuclear bomb. So this was thousands and thousands of tons of TNT in terms of energy. But importantly, for both astronomers and geologists, this discovery demonstrates that the scale of impacts by a lot of these smaller rocks seems to have been much greater than we previously thought. Or I guess just to rephrase this, these collisions potentially happen way more frequently than we believed. And so this crater provides us with a critical reference point, specifically reference for the rate and distribution of small hazardous objects that can still collide with the planet and produce massive explosions. Which actually brings us to my next point. Let's actually take a look at some of the other confirmed craters formed in the last 10,000 years, and what we actually know about them, and more importantly, how these impacts influence people living in those regions, because in some cases, there were actually already people living in a location nearby. First we have Campo del Cielo in Argentina. This site was formed about 4,200 years ago and translates to Field of Heaven. This is essentially an area containing at least 26 individual craters, with the largest one being about 150 meters across, but this also includes a lot of fragments, in this case classified as iron octahedrite fragments, with the site essentially representing the source of the heaviest set of meteorite fragments recovered on the entire planet. Here scientists discovered approximately 100 tons of rocks, many of them as leftovers from the crater formation. And not surprisingly, because we know that people already lived here, this impact was known to the local aboriginals, who reported this as something falling from the sky to some of the earlier Spanish explorers back in the 16th century. Now unfortunately I could not discover the actual stories about this or anything in regards to oral traditions, but it's clear that someone was here to witness this, even though it happened over 4,000 years ago. Then a more intriguing location is once again in Australia, the Henbury meteorites. This is literally as close to the center of Australia as you can get, and is considered to be one of the world's best preserved examples of a small crater field. Here there are 14 craters, anywhere from 7 to 180 meters. And well, interestingly, this impact also occurred around the same time, 4.7 thousand years ago. The craters were formed by an iron-nickel meteorite that, just like the previous one, broke apart before hitting the ground. But what's more intriguing here is that, well, Australian Aboriginals usually have an extremely rich oral tradition about most of the events they witnessed. And so this site holds a very high cultural significance for several local people. For example, the Arrernte people, whose name I'm sure I just mispronounced, describe this as a fiery devil, a devil coming from the sun. And they actually do have quite a few songs and stories about this, which implies that once again they seem to have witnessed this and managed to maintain the memory of this event for nearly 5,000 years. But then we have something very similar in Europe, specifically in Estonia. The Kali crater, which possibly formed approximately 3,500 years ago, is also a group of 9 craters on the island of Saaremaa, with the main crater being approximately 110 meters across. It also forms this beautiful circular lake. And this event very likely happened during the Nordic Bronze Age in a relatively highly populated area, suggesting that this very likely had a lot of impacts on the local population. As a matter of fact, because this impact produced something very similar to a Hiroshima bomb explosion, it most likely completely terrified most of the people living in this region. Here the entire forest was incinerated up to 6 kilometers away from the site, with the explosion itself very likely still audible at 100 kilometers away from the site. And today a lot of scholars suggest that this event seemed to have played a major role in local myths and traditions, with this site eventually becoming some kind of a very sacred place and possibly being used as a place of ritual sacrifice. And so this possibly had a major impact, pun intended, on a lot of Nordic cultures in the region, with even the local stories from Finland possibly reflecting on this event. For example, there's a story of a Luhi, an evil wizard, who steals the sun, plunging the world into darkness. But the guy Ukko orders a new sun to be created from a spark, which accidentally falls and hits the ground at a lake. And well, that story does sound kind of similar to what we're seeing here. As a matter of fact, there's even mentioning of this island being the legendary Thule, which means fire in Finnish, and is possibly connected to the story of the sun going to rest in a lake on an island. And while this is a lake on an island, where a collision created something resembling a small sun. And so here we have an example of a relatively recent crater that possibly influenced mythology around Northern Europe. But we also have a crater called Morasko in Poland that's also made out of 7 parts between 11 and 100 meters in size. And this one very likely also formed 5,000 years ago. Now, there is no known mythology associated with this impact, but we know that people used to live in this region as well, so someone had to have witnessed it as well. Okay, we have a few more to go, but in this case, there are no more stories and no more legends, mostly because either those locations were too remote, or because people that used to live in these locations have long moved on. For example, here we have something that happened less than 5,000 years ago in a very remote location of Egypt. This is known as the Camille crater, and so this crater was very likely formed less than 5,000 years ago as well, but seems to have happened around the time when Egyptians already moved away due to a dramatic shift in climate in this region. As a matter of fact, this crater is one of the most well-preserved craters on the surface of the planet, simply because it landed in an extremely dry region with almost no erosion. Here you can even see the ray system emanating from the middle that normally disappears pretty quickly following the impact. This is essentially the ejecta produced by the impact itself. But this is also not a very large crater. It's only about 50 meters across and was very likely formed by something that's only 1.3 meters wide. So it's quite likely that the ancient Egyptians didn't even notice it. Another less known crater in Australia is the Viviers crater that was also discovered by accident from the air back in 1975. Here there are no legends or stories about this, so we are not sure if anyone witnessed it, but we know it seems to have happened in the last 4,000 years. And last but not least is the Wobbler craters. Several craters up to 116 meters across that also seems to be very young. As a matter of fact, this could be the youngest crater discovered, maybe even less than 250 years old. And here this particular explosion was very likely witnessed over Riyadh in the 19th century, as several different reports mentioned something in the skies. But they didn't really see the explosion itself, and it was only discovered centuries later during some of the 20th century prospecting missions trying to find oil. Okay, so we've covered quite a lot, but basically, what's the point? Well, here we have a kind of a true record of Earth's impact history. Since most ancient craters are gone, studying these younger features provides us an important basis for understanding the actual distribution and, of course, the overall impact rate for some of these somewhat dangerous bodies. For example, the newly discovered Jinlin crater that's 900 meters across, and all of the previously discussed craters as well, prove one crucial point. Earth seems to be continuously bombarded by relatively large rocks, with many of them producing really large explosions equivalent to a somewhat small nuclear bomb. But this discovery specifically shows us that the scale of these impacts was dramatically larger than we previously thought. Nobody actually expected to find such a large crater from such a large explosion during the Holocene period. Although here we also have to briefly discuss one little side note. The idea referred to as the Younger Dryas impact hypothesis, or the proposition that's now been more or less disproven that some kind of a major cosmic catastrophe approximately 13,000 years ago caused a rapid global cooling and eventually resulted in the demise of most of the larger animals and some human civilizations. And so basically here, a major impact caused worldwide climate change, megafauna extinctions, and cultural shifts. However, when focusing mostly on facts, most of the evidence so far suggests that it actually didn't happen. Today, this idea is widely rejected by most experts, and mostly because in some of the previous studies, the actual evidence could not be reproduced and was possibly even faked. You can learn about this in one of the previous videos in the description, but in essence, despite this being a pretty cool explanation, so far it seems to have been incorrect. But there was always this one thing that the proponents of this idea wanted to find: an actual crater. In order to have such a massive impact, they needed a crater formed in the last 13,000 years that could be responsible for some of these effects. And just so that we're clear, this Chinese crater is not it. None of the confirmed craters we've discussed today, including Jinlin crater, provide any evidence for this hypothesis, mostly because their age is just dramatically different, and all of these craters are just so much younger. All of them happened way past the Younger Dryas, and though previously the Hiawatha crater in Greenland was possibly speculated to be one of these, This was pretty quickly disproven because it turned out to be much older at maybe 58 million years old, not 13,000. And so the main point of most of these discoveries is just the fact that a lot of these smaller, harder to detect rocks still actually produce quite frequent collisions, and even today we actually still have trouble detecting them in outer space. Because even this crater was produced by something that's just 30 meters across, and so discovering such a rock coming toward planet Earth would be somewhat challenging. As a matter of fact, modern studies suggest that up to 40,000 such asteroids could be in orbit close to the planet, and so the chance for a similar collision in the next few hundreds of years is pretty high. But obviously we'll have no idea where it would land. Anyway, we'll definitely come back and discuss this more in some of the future videos because this is just a really fascinating topic. But if you want to find out about some other craters, check out some of the previous videos in the description. Thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.